Welcome back, and now what we're going to do is we're going to start talking about complex numbers again. So complex numbers are numbers that are in the imaginary plane or the complex plane. And we talked about it before when we were talking about De Moivre's theorem and dealing with plotting complex numbers. So I'm going to do a little bit of review that we did back then to set up the idea, because the next thing is, okay, we want to get to writing these in polar form, okay? Which we sort of did before when we were talking about De Moivre's theorem, okay? But let's start over and let's say, okay, if I want to plot this, remember, we plot this on the xy plane like we normally would, like with any real number, except the y-axis is no longer the real number axis in the y direction, it's the imaginary axis. So the x-axis is going to be our imaginary axis, and the y-axis is now the imaginary axis, and we're going to plot each point exactly the same way. For example, in this imaginary number, this complex number, and again, remember it has two parts, right? We have the real part and we have the imaginary part. So the complex number is formed by those two parts, okay? So this is the real part, this is the imaginary part. So the I goes along this. So you could think of this as the I-axis, okay? So we would go 2 to the right, and then -3, which means we're going to go down in the imaginary direction, or I. So it would be 2 and then -3. So we would plot this by going 2 to the right and 3 down. And so our point would be there. And that would represent the complex number 2 minus 3i. Okay, now, there's another aspect of this, and this is learning how to take the absolute value of a complex number. Okay? So why is that important? Because when we're dealing with complex numbers, the absolute value of a complex number tells us the magnitude of that number. Okay, especially when we get into vectors later. Okay, so the magnitude is actually the distance. So in physics, we talk about the magnitude of a vector, the magnitude of a force. And so in physics, we talk about vector forces. And a lot of those times it's going to be maybe in a complex form. Okay, so when we talk about a magnitude of a complex number, we're actually talking about the absolute value of the complex number. And also, what does that mean? It means the distance that point is from the origin. Okay? So that distance. Okay? So now, you might have an idea of where we're going with this, right? Because we talked about, not only because we talked about this before, but this distance. Well, where have we found the distance before when we're talking about the distance a point is from another point, or the distance from the origin? Well, this is where the distance formula comes in. So what does this mean? Well, if I have a complex number, let's say equal to z, well then the absolute value, or what we call the magnitude of z, is nothing other than the distance formula. Okay, so it's going to be the distance of which parts? It's going to be the real part and then the imaginary, the coefficient on the imaginary part. Okay, so that becomes, and since we're dealing with the origin, the distance formula is simplified, and it just becomes a squared plus b squared, okay? And so that's the magnitude of a complex number, okay? Why? Because remember, the standard form of complex number is a plus bi, and so that's where the a and b come in. So, for example, if I wanted to find the magnitude of this number here, right? If I wanted to find that the magnitude of this complex number z, then I would just put in 2 squared plus negative 3 squared, which would give me the square root of 13. And so that would be the absolute value of the complex number, or what we call the magnitude. And of course we use the absolute value symbols for that. Okay, that's it. Have a great day.